Hello and welcome everyone. This is Mohammed Izamon from SAIMEDHA ECET Coaching Center, Koti, Hyderabad. In this video lecture series of physics sadhana, we are discussing about physics important topics based on the ECET PYQs analysis and important questions. So this is the next video in the physics sadhana series. Already we discussed about two topics, that were thermodynamic processes and ideal gas laws, both part 1 and the part 2. In and around some 4 video lectures we have completed. This is the 5th one, so make sure you have already watched those video lectures too, because they are also very important topic as per the ECET examination. Okay, moving on to the next topic, that is perfect gas laws. In this perfect gas laws, the ECET PYQ question number 1 given over the board is, observe the question which appeared in the ECET 2010. For ideal gas, the internal energy is, this law is called as Joule's law. This Joule's law states that internal energy of ideal gas, perfect gas, is function of temperature. Is a function of temperature. That means internal energy is directly proportional to temperature. Internal energy increases, temperature increases. Internal energy decreases, temperature decreases. Internal energy constant, then temperature is also constant. So we can write like this: change in internal energy directly proportional to change in temperature. We can make a formula also here: du is equals to proportionality sign gone, we need to put a constant, and the constant is Cv. This is dt. Total internal energy we require, so we need to multiply the mass. du equal to mCv dt. This is the formula. Go through it. So now what we have understood, that internal energy is U, which is dependent on temperature. Is it dependent on pressure? No. Is it dependent on volume? No. Is it dependent on the size? No. Independent on volume? Yes, it is correct. If it is only dependent on temperature, that means it is not dependent on any other parameter. Internal energy is dependent on temperature only. If it is dependent on temperature only, that means it is independent on any other property, independent on pressure, volume, etc. So this is the most suitable correct answer. Okay, go through it once. Moving on to the next question. Two thermally insulated vessels V1, thermally insulated vessel V1 and V2 are joined with a valve, filled with air at temperature T1 and T2. Its temperature is T1, its temperature is T2. They are joined by means of a valve of pressure P1 and P2 respectively. If the valves joining the two vessels are open, the temperature inside the vessel at equilibrium. What is the final temperature? He is asking. What is the final temperature? You know, when these two are going to be mixed with each other, the number of the moles are going to be getting added up. Okay, energy is going to be getting added up. So we can write the formula: the total amount of energy will be energy possessed by the symbol 1 plus energy possessed by the symbol 2. Where energy is, formula for energy is 3 by 2 times of n into k into t. That is n times of constant t. If 3 by 2 is a constant, k is a constant, it is a function of n and t. That means total number of moles, final temperature, we can write like this: n1 t1 plus n2 t2, because energy is getting added up. So what is the final temperature formula going to become? n1 t1 plus n2 t2 divided by total n. Total n is n1 plus n2. Now the question is, what is this number of moles formula? PV is equals to nRT. That means n is equals to PV by RT. Anyhow, R is a constant, so we can write PV by T. So final temperature formula is going to become Tf is equals to N1 is P1 V1 by T1 into T1, that is N1 form. N2 is P2 V2 by T2 into T2 whole divided by P1 V1 by T1 plus P2 V2 divided by T2. Okay, go through it. So if you solve this one, T1 gets cancelled, T2 gets cancelled. Take the LCM here. What is it gonna become? Okay, in the numerator we'll be seeing only P1 V1 plus P2 V2 divided by, this will become what? P1 V1 T2 plus P2 V2 T1 whole divided by T1 T2. The T1 T2 will be goes to the numerator, T1 T2. Okay, so this is your final answer, which is given in the option number 1. Go through it. Pause the video, note it down. Let's move on to the next question. Question number 3. A mass of 300 gram, that is mass is equals to 0.3 kgs. G value is given as 9.8. H value is given as 3 meter. You know the energy formula is equals to M into G into H, where M is 0.3, G is 9.8, H is 3. You can write like this, this is 3 by 10 into 9.8 into 3. 3 3s are 9. 9.8 into 9. 9 8s are 72. 9 9s are 81. 81 plus 7. 81 plus 7, 88. Okay. 88.2 it's going to become. Actually, if it is around 10, it's going to become how much? 98. But it's only 9. So, you should be careful with the values. The values are going to become what? 88.2 now. So, the total value, this is 3 3s are 9, this is 9 8 is 72, 9 9s are 81, 81 plus 7 88, so this is 88.2 divided by 10. This is going to become 8.82. This is the energy which is coming in terms of water joules. Asked the question is in terms of water calories. We know that 1 calorie is equals to 4.2 joules. So now you need to divide this value, 8.82 divided by 4.2. Okay. What is this 4.2? 2's are 2 2's are 4, 2 4's are 8. This is 8.4 it is going to become. 2 calories there, 2.1 calories also there. So if I am going to multiply here 42 into 2.1, okay, 4.2, 2.1, then what is it going to become? Let's see, 1 2's are 2, 1 4's are 4, 2 2's are 4, 2 4's are 8. 2 as it is 4 4, 8, this is 8, this is 8.82 now. So exactly 2.1 is getting cancelled. So 4.2, this is 2.1. So what is the correct answer going to become? 2 calorie or 2.1 calorie? It is 2.1 calorie. When the options are given so near, you have to be very careful. Okay. So the correct answer is going to become 2.1 calories. Okay. Let's move on to the next question now. Moving on to the next question, which is given in the year 2017. Question given is Boyle's law. There are actually 3 laws. Boyle's law, Charles' first law, and Charles' second law. We will be discussing with the students in this manner that all of the 3 you need to memorize like this: PV by T, PV by T, PV by T. That is ideal gas equation. And Boyle's law, cancel the temperature, temperature is constant. Charles' first law, cancel the first element, that is pressure is constant. Charles' second law, cancel the volume, that is volume is a constant. Okay. So temperature remaining constant, this process can be regarded as isothermal process. Pressure is constant, this is called as isobaric process. Volume is constant, it is called as isochoric process. Volume constant is represented by another law, that is called as Gay-Lussac's law. Temperature constant, that is PV is equals to constant, it is given by one more law, that is hyperbolic law. So now is talking about Boyle's law. Boyle's law, temperature constant. Temperature constant is related to which process? Isothermal changes. That is temperature is talk about. Okay, go through it. Pause the video, note it down. Let's go on to the next question. Moving on to the next question given over the board in the ECET 2019. Question given is temperature of 5 gram of air is raised from 0 to 1. Increase in the internal energy of the air is dash. In terms of erg he is asking. Okay. Focus on the units in this chapter. In this question, du equal to m into cv into dt. Where mass is given as what? 5 grams. cv is given as 0.172 calorie per gram degree Celsius. Change in temperature is 1 minus 0. 1 minus 0, this is degree Celsius. So what happens to degree Celsius now? Degree Celsius gets cancelled. What happens to the gram now? Both gets cancelled. So now you need to multiply this to 5 into 0.172. 0.172 into 5. 5 2s are 10. 5 7s are 35. 36. 5 1s are 5. 6 7 8. So 0.860. So this is going to become your value 0.860. Gram, degree Celsius. The only unit left out is what? Calories. This is in calories. Okay. Now he is mentioning that J value. The formula for W is equals total energy is equals to J into H or J into U you can say here. That is energy. Okay. So this du is none other than what now? Energy. Let's say it is H's. So in the place of H we can multiply here what? In the place of H we can multiply the value of 0.860. So J value is given as 4.18 into 10 to the power of 7. Focus on the unit. Erg per calorie into, what is the value that we have got? 0.860. What is the unit? Calorie. Now calorie gets cancelled. This is the calorie, this is the calorie. These both gets cancelled. Now your answer would be what in terms of ergs? So now you need to multiply 0.860 into 4.18. Let me take the value for only 86 and let's say this is 418 irrespective of digits. Okay, anyhow the values are going to be in terms of ergs only. So 6 8s are 48, 6 1s are 6, 7 8 9 10, 0, cancel here. 6 4s are 24, 25, 8 8s are 64, 8 1s are 8, 9 10 11 12 13 14, 8 4s are 32, so it's gonna become 33. Approximate values, let's see, 8 4 9 5 3. Okay, so if you want to take the units now, 4.18 and this is 0.86, so 1 2 3 4 1 2 3 4 3.595 into 10 to the power of 7. So this is going to become your final answer, 3.595 into 10 to the power of 7 ergs. Be careful with the units in the examination. So this is your answer. Go through it. Okay. Moving on to the next question. ECET asked 2020. Question asked is convert the minus 15 degrees Celsius into Fahrenheit scale. We know the thermometric principle. Thermometric principle formula is temperature in degrees Celsius, its lower fixed point divided by upper fixed point minus lower fixed point. In Fahrenheit, minus 32 divided by 212 minus 32. In Kelvin, K minus 273 divided by 373 minus 273. In terms of Rankine, 492 divided by 672 minus 492 is equals to, in terms of Reamer, R minus 0 divided by 80 minus 0. Usually these two are very important. So here given C by 100 is equals to F minus 32 divided by 180. Given value is C. C is minus 15. Substitute the value. What is it gonna become now? Minus 15 divided by, this is okay, with 5 we can say. Okay, this is 2, this 0 0 gets cancelled, 2 5s are 10, 2 9s are 18. So this is 15 divided by 5 is equals to F minus 32 divided by 9. Okay, 5 ones are 5, 3s are 9, 3s are 27. Minus 27 is equals to F minus 32. Minus 32 coming to the left hand side, it is going to become plus 32. 32 minus 27. 3 here, 2 there, 5. F is equals to 5. So what we can write? Minus 15 degrees Celsius is equals to 5 degree Fahrenheit. 5 degree Fahrenheit. This is going to become your final answer. Go through it. Okay. Moving on to the next question. Is it always true that du is equals to cv dt? We have taken that Joule's law. Question number 1. Joule's law, question number 1. In the question number 1, I said that Joule's law talks about internal energy of which gas? Ideal gas. This is the perfect gas law. This is a perfect gas law. Ideal gas law it is. That means it is going to be valid for, that is internal energy is a function of temperature, from where we got this formula du equal to mcv dt. Now the asked question is, du equal to mcv dt is valid for which gas? Ideal gas it is. Okay. That's the question up here. Is it always true that du equal to cv dt? Yes. No, it is never true. It is true only for ideal gas. Yes. This is the possibility. It is true only for which gas? Ideal gas. Ideal gas. Perfect gas. Okay. Moving on to the next question. The first law of thermodynamics. What does the first law of thermodynamics talks about? It talks about net heat transfer is proportional to net work transfer. Okay. It means heat and work are proportional to each other. Heat can be converted to work, work can be converted to heat. That means they are mutually convertible. Heat and work are mutually convertible. Heat transfer is equals to internal energy plus work transfer. This is energy. This is also energy. So it is based on law of conservation of energy. That is, energy can neither be created nor be destroyed, changes from one form to another form. That means first law of thermodynamics is talking about what? Law of conservation of energy. Very simple question. Moving on to the next question, appeared in 2022. This is a repeated question now. A graph between the temperature on the x-axis. This is temperature on the x-axis and pressure on the y-axis. Pressure on the y-axis at constant volume. Volume is remaining constant. Then it gives a straight line intercepts x-axis at. Okay, let me give you the diagram now. This is going to become your diagram. This is the diagram usually we get, that is a straight line. This is the straight line which is intercepting the x-axis, intercepting the y-axis. Here temperature is equals to what? 0 degrees Celsius, but pressure is not equal to 0. Final pressure is going to become 0 at what temperature? At a temperature of minus 273.16 degrees Celsius. This is called as absolute zero temperature. Absolute zero temperature, or also called as 0 Kelvin. So where does it intercepting on the x-axis? At what temperature value? Minus 273.1516. Okay, let it be 15. Nearmost value given is 15. So this is the correct answer, minus 273. Similarly, you can remember for this also. That means it is temperature. This axis is temperature and this axis is what? Volume. And here pressure is remaining constant. Then also what happens? Here? You will be getting an inclined line. This is the diagram where you will be getting this final volume is equals to 0 at a temperature of what? At a temperature of minus 273.16 degree Celsius. That is, final volume becomes 0, final pressure will become 0 at a temperature of minus 273.16, and this temperature is called as absolute zero temperature. Okay, moving on to the next question. Now let's discuss about the important bits based on the laws of thermodynamics. Question number 1 given is, an ideal gas is allowed to expand freely against the volume, against the vacuum, in a rigid insulated container. Okay. Then internal energy increases, temperature increases, decrease in the internal energy but increase in temperature, none of these. Suppose we are having a chamber like this, which is insulated one. These lines representing that there is no contact. This is insulated container. To this insulated container, let's say we are having what, two partitions are there. Let's say this is chamber A, this is chamber B. In the chamber A, we are having what, some high pressurized gases are there. Gas. Here we are having what, gas. Whereas in the chamber B, it does not have anything. We are having vacuum. And now, when the partition is removed, let's say this is called as partition. When partition is removed, gases from A expands to B. Okay, now this expansion is called as what? Unrestricted expansion. Unrestricted expansion. Or is also called as free expansion. Free expansion process. Free expansion process, where temperature remains constant, internal energy remains constant. That's why this is also called as constant internal energy process. This process is having another name, that is called as constant internal energy process. There is no heat transfer, that means there is no work transfer, there is no change in internal energy, constant temperature, so differentiation of temperature is also equal to 0. And this process is called as which process? This process is called as unrestricted expansion, also called as free expansion, also called as constant internal energy process. Okay, go through it. So now, increase in internal energy, no, because internal energy is a constant. Increase in temperature, no, because temperature is a constant. Decrease in internal energy, no, because internal energy is constant. Increase in temperature, no, because temperature is constant. So which one is the correct answer now? None of this is the correct answer. Remember this? Expected question in the examination. So far not yet appeared, but expected. Moving on to the next one. A closed vessel contains some gas at atmospheric pressure and room temperature. It is then given high speed by placing it in a fast moving train. By placing it in a fast moving train. You are taking a box which is having some molecules. Molecules are having random motion. Molecules have random motion. Due to this random motion only temperature is going to be influenced. When you are going to be giving the train one motion, then what happens? These molecules will get some ordered direction. Okay, due to that ordered direction, the temperature does not change. Temperature is going to be what? Changing with respect to disordered manner. Okay, temperature is going to be changing with respect to random motion. But here you will be having an ordered motion. Ordered motion does not have any sort of influence on temperature. Or we can remember like this also, PV is equals to N into RU into T. Number of moles are constant, universal constant, gas is a constant, is a closed vessel. Closed vessel. Closed vessel means volume is what? Constant. And it's having what? Contains gas at atmospheric pressure. That means pressure is also constant. Then definitely temperature is also going to be what? Constant. Okay. We know that internal energy, kinetic energy of the molecules are going to be responsible for influencing the temperature. Greater the internal kinetic energy of the molecule, temperature also increases. But that motion is due to random motion. not due to the ordered motion, not due to the direction, one directional motion. So temperature does not get influenced with the speed of the train. So temperature will remains unchanged should be the correct answer. Okay. Moving on to the next question. Next question given over the board is Avogadro's number is the number of molecules present in. This is a standard question. Remember this, pressure is going to be what? Atmospheric pressure. Atmospheric pressure, that is 760 mm of Hg. 760 mm of Hg. Volume is going to be what? 22.4 liters. These liters can be written as what? 10 to the power of minus 3 meter cube. Already appeared a question in the examination, 2.24 into 10 to the power of minus 2 meter cube. He changed the option there. Right? So the correct answer is what now? 22.4 liters at NTP. Moving on to the next question. The next question given over the board is internal energy of an ideal gas depends only upon. Okay, that is the first PYQ. We already know this is a Joule's law. And what does Joule's law states? Joule's law states that internal energy is a function of what? Temperature. This is all time standard question, and definitely it is an expected question in the examination also. So what the correct answer should be? Temperature. That is given by which law? Joule's law. Moving on to the next question. The next question given over the board. This is the last question for this law. The gas law PV by T is a constant is true for isothermal, adiabatic, both isothermal, adiabatic, neither isothermal nor adiabatic. We know that isothermal and adiabatic both are ideal case processes. Okay, so it is going to be valid for all thermodynamic processes. The correct answer is both isothermal and adiabatic process. So that's all about the questions from the laws of thermodynamics. I'll be coming back with one more video in which we'll be discussing one more topic about the heat and thermodynamics. Consistently we are adding the videos in the YouTube channel in the playlist Physics Sadhana. Make sure you go through all the video lectures on time, evening 7 p.m. sharp. Okay, make a habit of coming to the YouTube channel on the 7 p.m. watch this video, practice these questions, write down, analyze yourself, expect the questions in the ECET examination, and definitely you will be performing well. Okay, those who wish to join in the SAIMEDHA Kuti Hyderabad, new batches are going to be started guys from this very week. So make sure you just come to the SAIMEDHA or contact our mobile numbers, download the app saimedha.in and be a part of successful journey, and definitely you will be getting good ranks in the ECET 2025. Okay, make sure to subscribe and press the bell icon to be notified for every update from the SAIMEDHA Hyderabad. Thank you very much. With such more beautiful content, we'll be coming back tomorrow. Thank you very much guys. Keep learning with saimedha.in.